Hello friends, this is Durga again from ITversity. In this video I will try to cover creating Hadoop clusters with some advanced features. Um, there are certain things you need to understand when it comes to EMR. EMR is cloud-based service, Hadoop as a service. So whenever you want to run a Hadoop cluster, you can provision the cluster and you can process the data for the time you want, and then you can terminate the cluster. Typically, you can have the data in S3 bucket and you can access the data from S3 and directly using your Hive queries or Hadoop commands. Both will work, or even MapReduce programs. All these things will work on top of S3 without making much modifications to the code. You just have to say the path to be in S3. But S3 is a cloud-based storage, and the performance will not be as good as having the data on the node itself. So when you actually create the EMR cluster, it uses EC2 to get the instances, and with each instance you will get a free instance store, which is local to that EC2 instance. So if you have the data already in HDFS while starting up the cluster, the processing of that data will be much faster than having it on S3. So that being said, we will try to see how we can configure our cluster or our creation of cluster in such a way that while cluster is coming up, you copy the data into HDFS, and then you run your programs and copy data back to S3 before terminating the cluster, and you can terminate the cluster. So I have a simple script in my GitHub account under code repository Hadoop EMR, and there is a script called hivescript.html. In this, what I'm trying to do is I want to copy the files in S3 bucket into HDFS. So this is the HDFS location. I have shown this script even as part of the previous video, but I have run one command at a time. In this video, we will be using this script in such a way that while the cluster is coming up, all the steps are executed automatically. And the next command is to create an external table on top of S3 bucket, and also create an external table on top of the data which is copied into HDFS, and then we will run some queries on it to validate that it is working. Typically on a production type of environment, if it is simple, you can do this. If not, you have to use some scripts or tools like Azkaban to define the workflows, and Azkaban understands all these things, and you can execute shell scripts also. So you can put a create EMR cluster command as part of the shell script, and you can define workflows using Azkaban or any other similar tool. That's more advanced thing. But for now, if it is just simple, if you have a simple use case where you want to process data for a simple report on regular basis, you can name the directories accordingly, and you can parameterize, and you can actually use this feature which I am showing you now. So first, create cluster. So instead of quick options, we will go to advanced options, and you can choose whatever tools you want. These are the core components: Hadoop, Pig, Hive, and Hive. If you want Ganglia, Spark, etc., you can enable them by just checking them like this, but I don't want all these things. And then if you want to have any additional things, means if you want to customize your configurations, you can do that here. Okay, so you just have to say syntax like this: So if you want to update a particular parameter in coreset.xml, you can say classification equal to config file name properties, and you have to give the name here, config file name. So classification equal to, you have to give coreset.xml or hiveset.xml, etc. And then whatever properties you want to override, you can do that as part of this enter configuration. And then you can use add steps, and you can choose whether it is a custom jar or a pig program or a hive program or a streaming program. Whatever it is, you can choose that. In this case, we will be using hive program. And I don't want to terminate the cluster after the step is completed, so I am clicking configure, and in this case I want to, I named it as hive program, and I have to get the location of the script, which I already copied to S3. So I am going to S3 hive scripts, and the script is the same as whatever I have shown in GitHub. So I am choosing that script, select, and there is no input or output location. If you want, you can define those things. And there is no arguments. If it is a jar file, then you have to specify the arguments here. Or even if you want to pass the variables, probably you might be able to pass from here. I'm not 100% sure though. And then action on failure, I just want to continue even if it fails, and click on add. And then if you want to add more steps to it, you can actually do that. So it's not just one step, you can define as many steps as you want while creating the cluster. And then click on next. And now you can see whether you want to use VPC or classic. I am using classic only for simplicity's sake, but if you already have VPC, you can use VPC also. And then the types, master, core, and task. There are three types of types in advanced configuration. Masters are the ones which will have name node, data node, name node, resource manager, ganglia. All these are considered as master. And then core will have HDFS as well as node manager on them. If you don't understand what is HDFS, what is node manager, you can go to my Hadoop administration course, and I have covered them extensively. Data node is for name node is for storage master, data node is storage slave, resource manager is processing master, and node manager is processing slave. In this case, masters are name node, which is storage master, and resource manager, which is the processing master. And then monitoring tools like ganglia are also categorized into masters. When it comes to core, it have both node managers as well as data nodes, which are slaves for processing and storage respectively. When it comes to task, it will only have node managers. So there could be a chance that you might want to have data on fewer nodes, and then have additional processing power while running the commands, very heavyweight commands. So you can change the task, means you can scale up and scale down the task nodes when the cluster is up and running, but masters you cannot scale up and scale down. When it comes to core, I think you can scale up, but you cannot scale down. So if you understand the spot concept in AWS, by choosing spot for task, you can actually cut down cost significantly. The reason why you should not use spot for core and master are that the nodes might not be available at that time when you try to execute the scripts. So spot is if the resources are available, you will get it at a given price. Otherwise, you will not get them. For that reason, you should avoid using spot for core or master, but task, which you can use just to process the data, you can actually leverage the spot pricing and reduce your operational costs to process the data in AWS using EMR. In this case, I am just creating cluster with one master and two cores, and click on next. And this is the logging directory. You can give whatever path you want. It's better to give this so that all the logs are consolidated into one location. And if you want to debug, you can enable them. If you want to choose termination protection, you can do that. If you have termination protection, it will eliminate you accidentally terminating the cluster. You have to first disable the termination protection, and then only you will be able to terminate the cluster. So if you want to have that additional control to terminate the cluster, you can choose this. I am leaving it enabled. And then one more important aspect you need to understand is the bootstrap actions. So bootstrap actions, for example, if you want to run a Hadoop cluster and if it requires third-party jar files, and if you want to copy them on all the nodes in the cluster, or if you want to have additional software on all the nodes in the cluster, you can install them using Bootstrap. You can expand this, and you can have either run if or custom action, and you can choose run if and then configure and add, and then you can have a shell script in this location. You have to maintain something like this. And then you can also have custom action, and click on configure and add. You can have the jar file here, and you can execute whatever you want. But if you want to run shell scripts, then you have to use run if, click on configure and add. So run if is actually, it's a public S3 location. So if you want to run particular thing on all the nodes in the cluster, you can use this. Otherwise, you have to use custom action like this, and click on configure and add. And you can specify the path of your shell script also, or if even you can give the jar location. The name is a little bit misleading, but you can actually give the shell script also, and then you can actually pass the arguments. And if you want to understand more details, you can just click on learn more, and they provide the details about how you can leverage run if bootstrap action and also use custom bootstrap actions using command line, but you can easily relate with the user interface also. That being said, I don't want to have any run if nor the custom actions, so I am clicking on next. And proceed without an EC2 key pair. You have to be very careful. Here you have to specify the EC2 key pair, otherwise you will have challenges to logging into the cluster. And then permissions, I just want to have default. If you want custom, you can use custom also. And then in security groups, if you want to modify any of the security groups, you can do that by clicking on these things. You can go to the security group and then modify them, and also you can change the security group also. If you have your default, your custom security group for the clusters, you can do that. Security group is nothing but firewall, Amazon version of firewall, where you can open up or restrict access to certain ports in the cluster. And encryption, I'm not sure, I never use the encryption, so I will not be focusing on that much. And then you can click on create cluster. It will start creating the cluster now. It will take few minutes, and once it is done, I will review what all is done, and also we will validate whether the script that is part of the Hive is automatically executed or not. So now the cluster is created, and even the step, which is the Hive program, is also executed. You can click on view logs and get the details of the logs also by clicking on this, and also you can actually see what all jobs it has submitted if it is map reduce jobs. That being said, now let us validate whether we are able to access those two Hive tables that are created as part of the step while creating the cluster. So we need to get the elastic IP for it and then use SSH to connect to it. And you have to use the key pair, and Hadoop is the user at the IP address. It should start with AC2 and hit enter. Type S and now we are in the cluster. Now I can type Hive and hit enter, and then show tables. You can see both the tables are created, and also we can actually validate the data by running simple Hive query with limit 10 and hit enter. Now you can actually see the data also. Now you can run whatever queries you want, and you can actually create an external table pointing to S3 location, and you can actually insert into the final table, and then you can terminate the cluster. For example, you can say create external table NYSC 2009 aggregated as so I have to specify the location so that it goes to S3 location. Let me give the appropriate location. I am going to my GitHub account, and I will say input and NYSC 2009 aggregated. This is just S3 location as select. The first column is stock ticker, comma sum of volume from what is the table name. We can choose either of the tables. I will be choosing this one, which is in HDFS. Paste group by stock ticker. So I am just aggregating the volume for the year 2009 for the data we have, and hit enter. Okay, I cannot create external table for this. Okay, I can even create the manage table. There is no problem with that. Create table, hit enter. I can specify the location. If you want, you can specify the delimiters also. Hit enter, and then as select and hit enter. Now it is submitting the MapReduce job for the Hive query. It will just take a while, and then we will see the results. So now the table is created. I can say select star from NYSC 2009 aggregated limit 10 and hit enter. I can see the data, and now I can actually exit from it, and from this also, and then actually I can terminate the cluster, and still you can preserve the data in S3 Let me terminate the cluster. Okay, before terminating the cluster, one more thing which I want to emphasize is that whenever you recreate the cluster, your master public DNS will be changed. So if you want to use the same public DNS for the script, so when you try to use AWS, you should use the web interface only for the first few times until you get comfortable with. Once you are comfortable with, you should be able to create the clusters using the AWS command line interface, and you should take everything. You should do everything using that. By developing the scripts. When you develop the scripts, if this public DNSs change every time, then it will be a little bit challenging for you. So instead of using the default public DNS, what you can do is you can go to AWS console. I am opening AWS console on a separate window, log into the console, and then you can actually click on EC2, go to EC2 console. You can see 3 running instances, and there is the concept of elastic IPs, wherein these IPs you can reserve them by paying moderate charge for each of the public IP or for each of the permanent elastic IP. But it has to be EC2 because we have used EC2 classic while creating the cluster, but this belongs to VPC. So I can say allocate new address. I want it for EC2. Yes, allocate. Now there is a new IP. Click on actions and click on associate address, and here you can expand these things, and whatever instance you want to connect to on regular basis as part of your scripts, you have to pick that instance. So let us see what is the typically we will use master to connect one of the masters. If you have multiple masters, you can click on the view EC2 instances, and you can get the EC2 instance ID, and here you can 9D. Yeah, this is the one. This is the master. Click on associate, and now you will be able to connect to this instance using this new public IP, not the old one. So now if I try to connect here, it will not work because the IP is already changed. You can actually connect using the new public DNS or public IP. And hit enter. Now you will be able to connect to it. What happened? Why it is not connecting? Yeah, this is the public IP. Yeah. Yes, it just took time. Now you are in the same cluster. The private IP will not change, but the public IP you can change. And now whenever you create the cluster using the instance ID, even using the command prompt, you will be able to associate the elastic IP to a particular instance, and then you can run your scripts without modifying the public IPs as part of your scripts. So now it is done. Now let us terminate the cluster. Again, before terminating the cluster, I want to show a few other things also. I'm going back to the console, and here if you want to scale up, you can click on instance groups and click on resize, and you can actually change the number of instances, and then check click on this green tick button, and then it will actually resize to 3. See, now it is showing 3 requested, so it will actually add one more node in a moment. Let us refresh this. And click on hardware. It will take little time, but the third one also will be added. And if you but I think when it comes to core, you cannot scale down once you scale up. If you have task nodes, which is just adding more horsepower to process the data by adding more CPUs without having HDFS on them, you can scale up or scale down anytime. That's the advantage of increasing the nodes using the tasks. And also you can actually click on add task instance group here, and you can add as many nodes as you want here for task instance group. So you can add them anytime, you can terminate them anytime. So what you can do is you can have 3 nodes or 4 nodes with 1 terabyte or 2 terabyte of storage. You can keep up and running all the time, but when you need more horsepower to process the data, you can actually add the task instance groups. Again, when you have too many task instances without not so many core instances, the data locality feature of Hadoop will be compromised, and the performance might not be very good. So you have to evaluate whether between the price and the performance. If you want the best of the best performance for your stuff, you have to spend more money. You have to use more core instances than task instances to store the data and process the data. But if the performance is not the major criteria, if the data is being processed in time, then you can actually add more task groups or task instances to cut down the cost. So this is how you can actually reset the cluster. You can stop when it is resetting also, and now it is stopped. Okay, so this is about creating the cluster on using custom method. And then if you want to terminate, you can just terminate, but it will not let you to terminate the cluster because the termination protection is on. You can change it by clicking on this, click on off, and then you have to click on the tick button, and then now the termination protection is off. You will be able to terminate the cluster. So it will take a while to terminate the cluster. While it is terminating, we will see whether we have the data in our S3 bucket or not. So I have gone back to the S3. The location is NYSE IT Varsity, input, and here you can see the NYSE 2009 aggregated data, which is generated because of the high query we ran. So this is how you can actually leverage the cool pay-as-you-go model of AWS to cut down your costs, and by clubbing S3 with Amazon EMR to process your data and store your data persistently on S3. That being said, that is it for now. As part of next video, I will try to cover how we can do all this using command prompt, because that is the most important thing when it comes to cloud-based technologies. You should be familiar with the command line so that you can actually script and schedule it and run it as and when it is needed without much interaction with web interfaces. So I will cover that as part of the next video. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you want to provide feedback, please use the comment section of the video. If you ask any technical questions, please go to Stack Overflow and ask on AWS EMR. I will monitor those, and I will try to respond to those to best of my knowledge. If you have not subscribed to my channel yet, please do so. I will be adding a lot more content like this over time. Thank you. Bye.